Hello, welcome to another episode. Today we'll be looking at sequences and series. So some general sequence series advice is that for percentages, try and write them in decimal form. And okay, during this question or sequence and series, if you ever not sure how to do it like through actual formulas, it is also technically possible to use your graphing calculator and manually calculate it. Although it is more tedious, you can still get the marks that way also. Then another thing you may want to remember is from your secondary school, which is the formula for compound interest where you take your original investment, which is like T, or like in this case A, times 1 plus the rate divided by 100 to the power of n, where n is your time period. So in terms of content, there's several parts. The first part will mainly be sequence and series, and then the other part will be what you'll be mostly tested on, which is arithmetic progression, AP, and geometric progression, GP. So in terms of what a sequence is a set of numbers like U1, U2, U3, arranged in a defined order according to a certain rule. This rule can be like a formula or something. So the number U1 is called the first term, and UN is the nth term. So a sequence can also be called a progression, and a sequence is finite if it terminates. Otherwise, it is an infinite sequence. What this means is that if it is finite, it will eventually converge or stop at a certain number. Otherwise, it will just go on for like infinity or negative infinity. So some examples of finite sequence is 2, 4, 6, 8, 10, 12, 14, 16. Because you know that it's all going to be odd number. It's not going to be even number. But in terms of infinite sequence, you see that 4 is 2 square, then you get 3 square, 4 square, 5 square, 6 square. So it's expanding on and on. So an example is the first three terms of a sequence is given by a quadratic polynomial in terms of n, where the first term is 10, the second term is 6, and the third term is 5. So you want to find the nth term. So when they say it is a quadratic polynomial, that means it's in the form an squared plus bn plus c, or like any other quadratic equation like x squared plus x plus c. So we let n equal 1, 2, and 3, where the result fx, or like fn, equals to 10, 6, and 5 respectively. And then we're going to get a system of three linear equations and solve them in a graphing calculator. So that's what you do. 10 will equal a times 1 square plus b times 1 plus c. That's your a plus b plus c equals 10. Then you have 6 equal a times 2 square plus b times 2 plus c. That's 4a plus 2b plus c equals 6. Then 5 equals a times 3 square plus 3b plus c is 9a plus 3b plus c equals 5. So putting all this into your graphing calculator, you end up getting this answer where a equals 1.5, b equals minus 8.5, and c equals 17. So another example is that for example 1, UN equals 3n plus 2, or a equals 1, 2, 3, 4. To find the fifth term, we're just going to substitute n equals 5, such that we get 3 times 5 plus 2 equals 17. So the sequence is just 5, 8, 11, 14, 17. And so from this, we can see that the sequence n goes on forever, so it's also a infinite sequence. Then, for example 2, a sequence is defined by un. So we have, however, n equals from 1 to 50. So the first term will be 20, the fifth term will be 25. Then the sequence will keep increasing, but it will stop once it reaches the last number, which will be 50 squared, which is 2500, and this will be a finite sequence. So a bit like tracking here. Okay, what I meant for this part is actually that this finite sequence being ends at 16. And then for the infinite sequence, it means it just goes on and on. Yeah, sorry, that's what I meant. Then about convergence of a sequence, there are several behaviors to describe the behavior of a sequence. So that's the general behavior. This can be such as a number increasing from 1 to 2 to 3 to 4, decreasing from 9 to 4 to 1 to negative 10. For example, it's just 2, 2, 2, 2. Or alternating, so you have a positive 1, then a negative 8, then a positive 27, then a minus 64. Then you can also describe behavior as a long run behavior or infinite sequence. So you can say whether it's convergent or divergent. What this means is that, for example, if you go from 10,000 to 1,000 to 100 to 10 to 1 to 0.1, it's slowly going to 0. Whereas in the case of 1, 2, 4, 8, 6, that's like 2 to the power n minus 1. So in that case, it won't keep going on to infinity. So the key idea is that the first example, it is converging to 0. The second example is diverging to infinity. If you're not sure whether it's converging or diverging, use divergence as your basis. If it is not converging, it is diverging, if that makes sense. Then for series, a series is a sum of terms in a sequence, U1, U2, U3, so on and so forth. And the sum of these terms is denoted by Sn equals first term plus second term plus third term, on and on until you reach the last term, which is the n term. So actually, if you want to get the n term, you can actually take the sum of the first n term minus the sum of n minus 1 terms. So in the case of the sum of the first term, it's just going to be the first term itself, U1. So on to arithmetic progression. An arithmetic progression is a sequence of numbers for which the difference between any two terms is a constant. So this basically means any term minus the previous term before it will equal d, where d is the common difference. And an arithmetic progression with first term a and common difference will be a, then go to a plus d, then a plus 2d, then a plus 3d, so on and so forth. So the nth term can therefore be described as un equal a plus n minus 1d. First time example of arithmetic progression is 2, 4, 6, 8, 10. So first term is 2, common difference is 195, 1985, first term is 20, common difference is minus 5. Then for that one, first term 1.5, then go to 4, 7.5, 11. So the common difference is 3.5. So looking at the sum of the first n terms of the arithmetic series, we can let Sn denote the sum of the first n terms of an arithmetic series with first term a and common difference d. And so a formula that you have to memorize is that the sum for all these terms can also be described as such. So it can be described as the number of terms divided by 2 times 2 of the first term plus n minus 1 of the common difference. Or it can be n over 2 times the sum of the first term and the last term together. So both of those will still give you the exact number you need. So for this example, find the number of terms in a arithmetic progression from 20 to minus 135. So you see that it goes from 20 to 50 to 10. Now, as long as you got three numbers and you can get a pattern between them, that's where you can confirm it's a series. If you just have two numbers, you are not able to confirm anything, but in this case you can. So for this case, the first term is a equal 20, the common difference is d equal minus 5. And we know that the sum will be n over 2 times the first term and the last term. So you can do that. So first, we need to find n. And so un equal a plus a minus 1g minus 135 equals 20 plus however many times or minus 5. In this case, our n is 32, so that's how we get onto the right hand side. Insert the 32 divided by 2 times 20 plus a negative 135, you get minus 1840. So that's the sum of all these terms. Then next question, arithmetic progression, first term 2 and n term is 32. Has the sum of its first n terms equal to 357. So find n, and in the case term has a value exceeding 100, find the least value of k. Or in other words, find the first term which is greater than k. Or I mean find the first term which is greater than 100. So we'll just use the formula again, where Sn equal n over 2 times the first term plus the last term. So n 357 equal n over 2 times 2 plus 32, you solve that, you get 21. So un equal u21 equal 32. So 32 equal 2 plus 20d, so d equal 1.5. How we got the 32 is because we know that n term is 32. And so like that, we're just going to use the a plus n minus 1g. So n minus 1 is just 21 minus 120. So for that, we then can get un equals 24 plus 1/5k minus 1. And to find that is greater than 100, we are going to solve the inequality, which in this case will be 66.3333. So because all these terms will be integer, that means the least k has to be 67. Now, for the proof of arithmetic progression, it falls back on what we previously learned. So to prove that a sequence is an arithmetic progression, we need to show that n minus the term before it is constant for all values of n greater than or equal to 2. And this constant is the common difference of the arithmetic progression. So for this example, the sum of the first n terms of a series is n squared plus 3n. So find the n term and prove that the sequence is an AP. First rule, so we're just going to take the sum of n terms minus the sum of all the terms before excluding that last n term. So it will be n squared plus 3n minus the same thing, but you replace n with n minus 1. To simplify, you get 2n plus 2. Then, with that, we know un. To prove it, we need to prove that un minus 1 is a constant. So that's what we do. 2n plus 2 minus 2n minus 1 plus 2, you get 2, which is a constant. And so since the difference between two consecutive terms is constant, the sequence is therefore an arithmetic progression. Then now on to geometric progression. So a geometric progression is a sequence of numbers for which the ratio of every two consecutive terms is a constant. So what this means is that un divided by the sum before it will lead to r, where r is a constant known as the common ratio. So a geometric progression with first term a and common ratio r will be as such as a as the first term, then you have ar, then ar times r, then ar. So the nth term of a geometric progression will also be un, and it will be a times r to the power of n minus 1. So some examples of a geometric progression will be as such. This thing goes to a to 4 to 2 to 1 to half to a quarter. So the first one will be 16, and then the ratio is 16 goes to 8. So that means it's by half. Then from 1/4 to minus 1 to 4 to minus 16 to 64. The first term is 1/4, and the ratio will be minus 4. So it can be a fraction, can be positive, negative, it can be any number. Or in the case of minus 4 to 4 to minus 4 to 4, the first term is minus 4, and then the ratio is just going to be minus 1. So for the sum of the first n terms of a geometric series, we let Sn denote the number or the sum of the first n terms of a geometric series with first term a and common ratio r. So Sn will equal a times r power n minus 1. So that's the numerator divided by r minus 1. Or you can also swap the internals around. So it can be a times 1 minus r to the power n over 1 minus r, where r is not equal to 1. So how do you decide which orientation you want to do it? If the r is greater than 1, so like 2 square, or like 2 to the power n, then you will put it here. But if it's like 0.5, you'll move it here such that your entire fraction will still be like a positive number. So for example is this, in the GP will be positive. The third term is 18, the fifth term is 162. So find the sum of the first n term. So you know that the third term, which is equal to a r square equal 18. Then the fifth term is a power 4 equal 162. So by right, if we take the fifth term divided by the third term, you'll get r squared. And this r squared will equal to 162 over 18. R squared equals 9. Then r equals either 3 or minus 3. But we know that it cannot be minus 3 because they say all the terms are positive, so that's why we reject that. Then to find the sum of the first n terms, we're going to use the previous formula. So 2 times r to the power of n, and this is r is 3, the number of terms is 10. Minus 1, divide by the ratio, which is 3 minus 1, you get 59048. Then, likewise, for the proof of a geometric progression, to prove that a sequence in a geometric progression, we need to show that un divided by the term before it is a constant for all values of n greater than or equal to 0. And this constant is just the common ratio of the arithmetic, the GP. Yeah. So for this example, the sum of the first n terms of a sequence is a minus 2 to the power of minus n minus 1. So that the sequence is a GP and state the common ratio in terms of a. So Sn equal a minus 2 or minus n minus 1. Then to get the un, we're going to take Sn minus Sn minus 1. And if you do that and simplify, you'll eventually get a minus 2 power minus n times 3 minus a. Then to prove that it's a GP, we're going to take un, divide by un minus 1. To do that, you replace your n with n minus 1 for the denominator. Eventually, you'll get 1 divided by a minus 2, and that is a constant. Because your a is also a constant, so the entire expression is constant. And therefore, since the ratio of the two consecutive terms is a constant, the sequence has a geometric progression with the common ratio of 1 over a minus 2. Then, for example A, the first term of an increasing AP is 1. The sum of the first 5 terms, 10 terms, and 20 terms are consecutive terms of a GP. Find the common difference of the AP and the common ratio of the GP. So, if we try and lay out all the information down, we have the AP, where the first term is A equal 1, and the common difference equal D, whatever the D is. Then since S5, S10, and S20 are consecutive terms, it means that the S10 divided by S5 is the same as the S20 over the S10, and all this is equal to a common ratio, because these are consecutive terms in the geometric progression. So if we cross multiply, you'll get the sum of the first 10 terms 4 square equals the sum of the first 5 terms times the sum of the first 20 terms. And so if we do that, and we lay out all the information and express our S5, S10, S20 in terms of you'll get as such. Using the formula of NO2 times 2a plus n minus 1d, that's how you get S5, S10, S20. Then solving, you'll get either d equals 2 or d equals 0. And we reject 0 because if that's the case, all the terms will be the same. but it cannot be the same because there's a GP in the box. And so for we take a 2, and our common ratio is just going to be S10 divided by S5, or it can also be S20 divided by S10. You still get the same number, which in this case will be 4. Then another concept, which is only for geometric series, is that the sum to infinity. So consider a series, a geometric series, with first term 1 and common ratio 1 over 3. So the sum of the terms will just be 1 plus 1 over 3 plus 1 over 9 plus 1 over 27, and so on and so forth. So if you try and express it as sum, you'll realize using the formula of a times 1 minus r power n divided by 1 over divided by 1 minus r, you'll get 1 more time times 1 minus 1 third to the power n. So notice that as n approaches infinity, the sum to infinity actually approaches 1 by 5 times 1 minus 0. In this case, it's just 1 by 5 times 1 equal 1.5. And so there's actually a formula for the sum to infinity. So this sum to infinity Sn can be expressed as a over 1 minus r. So in this case, if there is a sum to infinity, we can say that the geometric series is convergent, and the sum to infinity will be expressed as such. S infinity equal a over 1 minus r. So an example is this. A GP has first term 1, ratio of 7 over 8. Find the least value of n for which the sum of the first n term is greater than twice the sum of the remaining terms. So if we put everything down, our GP will have a equal 1, r equals 7 over 8, and the n term will be 1 times 7 over 8 to the power of n minus 1. And what the question asks us is to find Sn greater than twice of the sum to infinity minus Sn. So if you do that, you express your Sn in terms of the formula, you get your sum to infinity in terms of the formula, and your Sn as well. Then you bring everything, simplify it together, and then you simplify the numbers here and there, you eventually get to the last part, which is n greater than ln 1 over 3 over 178. Why we use the ln is so that we can get rid of the power by bringing it down, and then we just manually solve the numbers that using the GP, which allows you to get n greater than 8.227. And since n has to be a whole number, that's why our least n will therefore be 9. Then another example is by using a geometric series, express the repeating decimal 2.353535 until you get a rational number, or in other words, a fraction. So if you try and break down the 2.353535, there's a pattern which is the 35. So what happens is that you're going to break it down into 2 plus 0.35 plus 0.0035 plus 0.0035, turn it into a fraction, and it's easier to visualize what it is. So we can express it as 2 plus 35 over 100 times 1 plus 1 over 100 plus 1 over 100 squared. So, and this thing will go on for infinity. So that's why we're going to get a sum to infinity, which will be a over 1 minus r. Simplify that, and so you get 2 plus 35 over 99, which is a rational number. Now onto the questions. I put 7 questions in here. So they will be about the sum of selected sums, comparing the sum of sums, building a layer cake where with each layer it gets smaller and smaller. Then I exercise program about how much distance we run. A ball dropping where with each bounce it doesn't bounce as high as it previously did. Then there's this other question about let's say h equals 0, 1, 0, 2, 0, 3. Then c will actually be the inverse of each term. Then there's another question which for Chong set, which was our fighter. So I'm gonna feature that as well. So for the first question, find the sum of the arithmetic progression 1 4 to 7 10 to 2. Then almost every third term is 3. Find the sum of the remaining terms. So for the given arithmetic progression, we know that the first term is a equal 1. Then the common difference is actually 3. So we let the last term be un, and the number of terms be n. So un equal 1000. This un also equal a plus n minus 1 d. We put it on a, we put it on d. We'll get n equal 334. Therefore, we can find the sum of all the terms as such. Then, after every third term is the sum of the remaining terms is the sum of all the terms times the sum of the removed terms. So we're going to find the sum of the removed terms for every third term. So the removed terms are 7, 16, 25, and this in itself actually forms an arithmetic progression, since there's actually a common difference of 9. So since there are 334 terms in the original AC, that's 3 sets of 111 plus 1. So what we're going to do is we're actually removing 111 terms. So we're going to find the sum of the removed term, which will be 111 divided by 2 times 2 of the initial term 7, 111 minus 1, times the common difference, which is 9, which is 55722. And so to find the sum of the remaining terms, you just do the subtraction and you'll get 111445. Then for the second question, there's a sequence of numbers u1, u2, u3, where the sum of Sn. It's known that the sum of the first three terms of the sequence is 17, and the summation of the sums is 30 for these three numbers. So furthermore, the third term of the sequence is twice the term of the first sequence. So you want to find the first three terms of the sequence. So this is kind of like a simultaneous equation question. So that's what we're going to do. We have all this information out. We can create three equations. The first equation will be our u1 plus u2 plus u3 equals 17. Then our second equation will be the sum of the sum 1 plus sum 2 plus sum 3 equals 30. Whichever one means u1 plus a u1 plus u2 plus a u1 plus u2 plus u3, which from the first equation we already know we have this equal to 17. Then for the last equation, we have the third term equal sign for the first term. We bring everything to one side, you get 2u1 minus u3 equals 0. Put it into the graphing calculator and you'll get that the first term is 4, second term is 5, and the third term is 8. Yeah. Then the second part is that a constant k is subtracted from each term of the sequence, so that the first three terms of the modified sequence is now three consecutive terms of a geometric progression with a common ratio greater than 1. So find the value of k and the common ratio of this geometric progression. So from our previous answer, we know that the first three terms is 4, 5, and 8. This new sequence will be 4 minus k, 5 minus k, and 8 minus k. So it's still a sequence, so we can take 5 minus k divided by 4 minus k equals 8 minus k or 5 minus k. In other words, the ratio of the third term over the second term equal the ratio of the second term over the first term, plus multiply, we can solve to get k equals 3.5. So if we have the k equals 3.5, we can then find the ratio, and if we solve that, we will get a ratio of r equals 3. Then for this next question is building a layer cake. So suppose a baker wants to bake a 1 meter tall birthday cake. It comprises of 10 cylindrical cakes, each of equal height of 10 cm. The diameter of the cake at the lowest layer is 30 cm. Then the diameter of each subsequent layer is 4% less than the diameter of the cake below. So find the volume of this cake. So for this question, we need to find the volume, and then what's the diameter. So what we want to do is we want to take the diameter, turn it into a radius. So 30 cm become 15 cm. Then we're going to find the formula for volume, which is pi r squared h. The h is always going to be 10 cm, so we'll leave it as that. Then we try and look at reference to the first layer, second layer, third layer. If you're not sure what the sequence is, it's best to try and lay out the first three numbers and try and observe the pattern. And so in this case, when there's 4% less of the diameter, what happens is that it's going to be 96% square for the second layer, and the third layer will be 96% square times 96% square. So actually, we have this common factor of 10 times 15 square times 5. Then for the total volume, we can just take that 10 times the sum of doses of 0.96. So this will equate to 250 pi times 1 plus 0.96 square plus 0.96 power 4. Put it into your GC or manually calculate the formula for that GP and you'll get 50309 cm. So that's your answer. Then for this next question, in an exercise program, the distance between points are such that from O to A1 is 4 meter, so like 4 meter, A2 to A3 is 3 meter. There's this formula where AN times AN plus 1 equals to AN minus 1 times AN. The runograms back and forth from O to AN, repeat in increasing intervals from A1, A2, A3, so on. So write down an expression for the distance from start n stages, and hence find the distance from O, and the direction of travel is exactly 10 kilometers. So the distance run will be 4 plus 8 plus 16 plus 50 times 2 because you're going back and forth. So we try and convert this one into a formula, and you realize that this equals to 2 times 4 times 2 power n minus 1 over 2 minus 1, where our initial term a is 4, and our common ratio will be 2. Simplify that, you get 8 times 2 power n minus 1. So we're going to look at exactly 10 km, which in this case means 10,000 as your distance in terms of meters. And you solve it, you get n equals 10.29. So what this means, it implies that This 10,000 per theory mark was reached after the 10 stage and on the way to the 11 checkpoint. So, after 10 stages, we covered the distance of, if you calculate from the previous formula, it will be 1816. Then, the distance between 4 and the 11 checkpoint will be A11 equal AR 1000, which will this case be 4096. So this means it will be traveling from O towards A11. Because after 610, you have to find the distance you traveled so far after that, which in this case you will have run 1816 meters from distance O, which isn't your 4096 yet, so that's why he's traveling from O towards A11. Then for the next question, if time a ball falls vertically onto the floor, it rebounds to 3/4 of its original height. It was initially dropped from 4 meters, so find the distance that the ball traveled until it's about to touch the floor on the m+1 time. So in this case, the first time will drop down 4, but that one is only going to be 1/4. But when it goes up and down again, you're going to have to multiply by 2 because you have the upward and downward movement which is registered. So in terms of the sum, you're going to have 4 plus 2 times 4 times 3/4 plus 2 times 4 times 3/4 square and repeat on where your 3/4 will be multiplied again and again. So in this case, you have 4 plus 2 times 4 times a sequence of 3/4. So simplifying that, you'll get 4 plus a times your a, which is 3/4 times 1 times r, the power n, your r is 3/4. Divide by 1 minus r, you get that. Simplify, you get 28 minus 24 times 3/4 to the power n. This next question is quite interesting. So given they're all terms in the geometric progression of functions, with the first term a and common ratio r, the sums for h and c are defined as follows. So h is going to show them u1 plus u2 all the way to plus un. Then c is going to be 1 over u1 plus 1 over u2 plus so on and so forth. So by expressing h and c in terms of a and r, do that h divided by c is u1 un, then express u1 times u2 times u3 so on and so forth in the form of h over c to the power of fn, where fn is a function of n. So we just try and solve the first part first. So if we convert h into a sort of GB terms with ratio r, we use the GB formula. So it will be a times 1 minus r power n over 1 minus r. Then for c, we're also going to do it as some of GB terms. Yes, that our initial term is 1 over a, and our ratio is 1 over r to the power n. Then if we try and summarize and split everything into a single part, it'll just be 1 over a r power n minus 1 times r power n minus 1 over r minus 1. Then if we do our h over c, we realize that it's basically going to be as such. A times r power n minus 1 over r minus 1, that's our h, times our c. But in this case, it's a times because we swap the denominator and numerator around. So that's how our a times r power n minus 1 go up, our r minus 1 go up, then our r power n minus 1 go down. Simplify because you have the a here, and r n minus 1 here, r n minus 1 here, r minus 1, r minus 1. We can simplify to a times a r power n minus 1, which in other words is just u1 times un. So that's how we get the first part. Then for the second part, express u1, u2, u3 in the form h over c fn. So we try and see what u1 times u2 times un all the way is. So it's going to be a times ar times ar squared times ar squared all the way to the time. So we can factorize it to a power n times r to the power of 1 plus 2 plus 3 and so on and so forth. So this itself is its own arithmetic progression. So we convert this ap into n minus 1 times n over 2. Then since we try and do some observations, we see that h over c is equal to u1 un equal to a squared over r power n minus 1 based on the first half of the question. So we try and compare and we try and force fit something inside. So if we try and turn this into this, we realize that we can get the 2 inside by dividing by then we can keep the n minus 1 here, put this n outside, and that's how we get our h over c to the power of l over 2. It's quite logical in the sense that you can see the step-by-step analysis, but it may appear daunting at first. So yeah, try not to be too scared. Just try and lay out all the information and see what you can relate, and try to see what the function is. Usually, whenever they have this like over fn, the fn will not be that complicated, so it should be something more manageable. Then for this last question, so one NIPO logistics commander was tasked to deliver goods to an army camp in Abdian during June 24. So commando delivered 1,000 tons of goods on 1st June, 1,100 tons on 2nd June, and each subsequent day the delivery was 100 tons more than the previous day delivery. And after several days, due to more drone attacks from Al Qaeda, the commander had to change of plan so that each subsequent day the delivery was 100 tons less than the previous day. So by 15 June, the commander managed to deliver a total of 21,300 tons of goods for the past 15 days. So on which day did the commander deliver the most goods to the camp? How many tons of goods did he deliver on that particular day? So there's a lot of information. So I try to type it out and try to highlight different parts to make it look more clearer. So the first day, 1,000 goods. Second day, 1,100. Then increase 100 each day. Then after a certain point, it started decreasing by 100, and the total is 21,300. So for this question, we have a certain pivot, and this pivot will be the x day where the most goods are delivered. So for this question, how we're going to solve is that we're going to assume the x day to be the day with the maximum amount of goods delivered. So this Sx, which is for the first x day, x over 2 times 2 of the initial, which is 1,000, plus x minus 1 of the common difference, which is 100. So this Sx for the first x day is x over 2 times 1,900 plus 100x. Then for x day to the 50th day, we are going to go from that middle day and then look onward. So the number of terms will just be 15 minus x divided by 2 times 2 of 800 plus 100x, whatever that x may be. That's our initial term, which will be the first day or like the maximum day of goods, or the day with the maximum of goods. Plus 15 minus x minus 1, which is the number of remaining terms, times minus 100. All that will equal 15 minus x over 2 times 200 plus 300x. Then, since we have that, actually the total number of goods delivered is 21,300. We're going to take the first x day, then the first x2. We're going to take first x day, then x day to 15th day. All that, those two sums together, equals 21,300. You solve for that, you get a quadratic equation. Simplify, you get x equal to 9 or 22. So, and we cannot accept 22 because the maximum number of x is 15. Therefore, by that, we found out that actually 9th June was the day when the most was delivered at 1,000 plus 9 minus 1 times 100, 1,800 tons. So that was how we end up solving the answer. Try and break everything down, and then we try to use something as a reference. And with that reference, we are able to find a way to get the individual sums and get the sum of the parts together and solve the question like that. So yeah, the x need not be n, like x equal n. We can have different sums, like different ways to express different values and unknown. So some recap of the different questions is that for like the first question, given that every third sum of a solution is zero, you find the sum of remaining terms by creating a new series using consideration several terms. So we look at a series with only the third term, and then we look at four terms, and then you take the bigger one minus the smaller one. That's how you get the remaining terms. In the case of question 2, like S1 plus S2 plus S3, this will be S1, which is U1, plus S2, which is U1, U2, plus S3, U1, U2, U3. Then for real life question is where they ask like specifically 10,000 people, you then have to look at between 10 and 11. So it's not after you solve and then you can stop there. There's a bit more also to get the rough mark. And then for question 7, it was very lengthy, it was an entire paragraph. But if you lay out all the information and create a reference point between day 0 and day 15, you can find a way to get the answer also. So that's some different ways you can answer these questions. So in summary, these are some stuff that you can memorize. So for AP, the sum will be A plus M minus 1B. The sum will be N over 2 times 2A plus M minus 1B, or N over 2 times A plus L, where A is the first term, L is the last term. Then there's no such thing as a sum to infinity for AC. But for GP, it will be in terms of A times R to the power N minus 1. The sum of GP will be A times R power N minus 1 as the numerator, so the denominator is then R minus 1. And then your sum to infinity will be A over 1 minus R. So that's for the AP, you find the common difference. So that's for GP, you find the common ratio. And then some other things is that for this thing called a Fibonacci sequence, the next number is the sum of the previous two terms. In case you ever see that, but it's a common sequence in mathematics in general. There are different behaviors you can describe a sequence such as increasing, decreasing, constant, alternating, convergent, and divergent. Un is the sum of n terms minus the sum of all the terms before that. And for the summation of 1, actually it can be like 1r equals 1, 2 times 3 times 1 over 5. It's actually just 1 through n factorial. So that's that. That's all I have. If there's any questions, you can always contact me on my Telegram. And I hope you learned something from this. And hope to see you in the next video. Bye bye.